Is Nish and this is Haylom. So we're going to be so our platform is a TalentTracker business. So it's essentially a scouting platform for amateur football players. It lets players upload highlights and connect with global scouts. So pretty much it demands high availability. It's a scalable infrastructure and uses data security as well. So we chose a full cloud setup as it would be cost efficient and it's globally accessible and it's pretty much good for scaling.
So following on to task one, it was basically just identifying the access management. The main thing being under the lab role here. We basically made sure that everything was going, especially the permissions down here. And then we moved on to task two, which is the VPC EC2 web server setup. So we first set up the VPC. This VPC was our lab VPC here, and we created two availability zones for it, and a public and a private subnets here as shown in the map. Go up. So we have the lab subnet, the private one, private two, public one, public two, and the route tables and network connections. We also went to the route tables and associated the private and the private and public subnets, and also connected the internet gateway. After that, we created a security group. The main security group being the web security group here. This basically is a main link to our lab VPC security, and here are the details as shown with the web security group. And the main thing of its feature was the inbound rules, where it accepts HTTP and SSH with their respective ranges 80 and 22. And then we created the EC2 instance, which was the main, we were going to deploy our EC2 instance being the lab server here. So this has all the IPv4 connections, and it's mainly connected with us, the main web server security group. We also make sure the instance is accessible through SSH connection, and places the instance and correct network for the security. And after we created the EC2, we could move on to task 3. Task 3 was mainly web feature deployment. We couldn't find the code whisper activity, so we created a unique feature. This feature was just a web app developed with a simple Python application. We selected lab server and connect and into the EC2 instance here. And what we basically did was launch the Python and run the Python file, which is basically here. It's a simple code here that runs here, and when you launch the application, it runs the script using sudo python app.python, which allows to run to the port 80, which is a HTTP access, and the EC2 instance securely groups and you can go to inbound port 80. Finally, we opened you can basically run the IPv4 address from the EC2, which is here, and when you put it in, it will show you hello from AWS EC2. This is basically the main feature that we had with our web server. It's simple but successful. We also tested it with another device, and yeah.
So moving on to question 4, which is basically instant scaling and monitoring. So pretty much we initially started off with enabling termination protection for the EC2 instance, which is being shown now. So as you can see, there's a tick near the enable. And the next thing we did was upgrade the instance type. So initially it was in T2 micro, so we had to stop the instance. Then pretty much we upgraded to T2 medium and reran it again. And as you can see, it's running now. And moving on to how CloudWatch was used to monitor performance and system logs. So pretty much search up CloudWatch, and then pretty much we created a dashboard which would display during high spikes during a certain period of time. It will show as seen here that during that time there was heavy spikes. That pretty much indicates the networking, and pretty much we set it up with 5 key indicators, which was network packets in and out, and network in and out as well, and CPU utilization, which was quite important. So this is essentially pivotal when it comes to applying in real world, where, for example, when there's high spikes, when there's scouts trying to watch highlights of or the game itself during tournaments, so they can get better perspective of players' traits and so forth. And moving on to task 5, which is storage expansion and backup. So essentially, in the EC2 instance, we created an EBS volume, then we attached it to the EC2 instance, which is seen here, and it's labeled lab volume. Essentially, we gave it a size of 20 gigabytes, and pretty much then configured to the file system, which is shown here. So we pretty much ran the df.h/h in the terminal, and pretty much it kind of indicated to us the dev x vdf, which is 20 gigabytes what we set. So pretty much it indicated to us that it was working well and the file system was configured well. And in regards to the EBS snapshot, so pretty much the EBS snapshot which is shown here. There's 2 other default snapshots, which was pretty much created by the autoscaling group, and the one we created is the my snapshot. So essentially, the snapshot would allow us to restore the volume in the future if need be, in case of accidental deletion or just any errors, pretty much. And moving on to task 6.
So task 6 was the main database integration part. Before we launched the MySQL database, we first created the security group for it, which was the database security group. It basically had the inbound rules for MySQL Aurora and port range 3306, and all traffic for outbound rules. It basically is linked with the web security group, which will help it connect to the lab VPC. And then moving on to RDS. Here we have we created our subnet groups, and here is the subnet group here, which is connected to the DB subnet, which is connected to the our DB subnet group we have created. This also helps to connect with the main web security group, and has also these private subnets 1 and 2. And after that, we launched our database with mainly linking it with the lab VPC, so it can be launched connected with the EC2 instance. This is basically the endpoint, and it's a T2 micro, and the monitoring also shows statistics for the CloudWatch. And basically, to test this database, we wanted to follow like the lab with the AWS details and then run the link, but it didn't show up, so we had to find an alternate method. What we basically did was install the MySQL in the EC2 instance here, and we had to download some files to make it run. And then after we did, what we basically run here is a mysql.h, and then the database, which this part is just the endpoint here. We'll just go back to connectivity, the endpoint right there, and then when you run it, it will come down here and ask you for the password. It's hashed, so you wouldn't be able to see what you're writing, but we did lab-password, and then after you enter that, you will be successfully entered with the MySQL environment. And then here we added our show database just to show that it works, with the database listing down below here. And we confirmed that it was successfully working, and tried it with the different databases as well.
So moving on to task 7, which is pretty much auto scaling and load balancing, and as we know, it helps with increased availability and scalability as well. So yeah, we were successful in creating the AMI from our existing EC2 web server, and use it to launch the instances behind or through load balancer. We also configured the load balancer to distribute traffic across these instances to improve availability and scalability as mentioned. However, during testing, we encountered a 502 bad gateway error when we accessed the DNS link, and this was primarily because we weren't able to successfully overturn the health status from unhealthy to healthy, as you can see here. So pretty much this is the reason why we could not kind of get access to the DNS link, because we pretty much messed up something that resulted in unhealthy lab instances. But overall, in summary, this project gave me a hands-on experience which helped me deploy and manage a scalable cloud-based web application using AWS. I also learned how to configure networking aspect of things, upgrade storage, how to create a database, and how to use monitoring tools like the line graph we showed early on. So pretty much all of these played a pivotal role in kind of strengthening my understanding of cloud computing in general, and also prepared me for any future cloud-based projects that I could encounter.
So adding on to Nish's, we also had the auto-scaling groups here, which were successfully launched. And this helped us to create for example, in the instances here, these 2 lab instances were run by the auto-scaling groups, although the target groups didn't work. The main thing with the auto-scaling groups did successfully work. But yeah, this project did help deepen also my understanding of cloud computing security, automation, and scalability. Although we did face many challenges, especially the RDS access issues with the security groups. We did have some issue running the database with the EC2 instances. But eventually we did overcome these by troubleshooting logs and redefining security groups and researching official AWS documentations. And now I feel much more confident in building an end-to-end cloud architecture. Thank you for listening to our presentation.